Everyone, welcome back. So we've got ourselves another regular polygon in which we're going to try to find its area. So the previous problem we did kind of guided us a little bit. It had already started to draw those right triangles. This one just has the outline of the polygon, kind of like the perimeter, and then also just gives us the length of one of the sides. Okay. So we're going to have to do a lot of the work ourselves. So let's start by finding the center, or just estimating the center, okay? And then we can draw line segments to two vertices, okay? Now, that's not a right triangle, okay? But it's an isosceles. It's an isosceles triangle, right? These two segments are the same length. So if we just go right down the middle, right, that's gonna be our right triangle. Okay. All right, so let's keep dividing this polygon into more and more right triangles and figure out how many we have. So I've already drawn two. So that's number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, 11, 12, 13, 14, 15, 16, 17, and 18. All right, so we have 18 right triangles that compose or make up this polygon. Okay. All right, so like the last video, I'm just gonna highlight one of these polygons. Okay. Sorry, one of these right triangles, excuse me. So this one right here. So we know we have a right angle. We also know because the entire length of this side is 6, then that distance right there is only 3 inches. And we can figure out the acute angle there, right? Because we know that the sum of all these angles is 360 degrees. And because there's 18 right triangles, you can just divide it evenly. Right, so 360 divided by 18 gives us a 20-degree angle. Okay, all right. So let's see if we can find the area of this orange triangle, and then we'll just times it by 18 to get the whole area. All right, so we'll do that over here. Okay, so I'm going to redraw the triangle, kind of laying down on its longer leg. Okay, so we know this is 20 degrees there. We know the short side is 3 inches. Okay. And so the area for a triangle is 1/2 base times height. Now we already have the height, it's 3. We just have to find the base, right, or this length here. Now, in terms of the trig ratios, right, this would be the hypotenuse, which we don't care about, we don't need that. This is the opposite side of the angle, and this is the adjacent side of the angle. Okay. So our goal now is to find the adjacent side, which would represent the base in the area formula. All right, so the tangent ratio is the one that relates the opposite and the adjacent side. Okay, it's opposite over adjacent, right? So TOA, T-O-A, tangent, opposite, adjacent. All right, so 20 degrees is our reference angle. So we'll write tangent 20 degrees. The opposite side is 3. The adjacent side, well, let me just call it A for now. Let's see here. Well, to solve this, I'm just going to make both sides fractions or ratios and then cross multiply. So I'm going to have A times the tangent of 20 degrees equals 3 times 1. Okay. Or what I could just do now is divide both sides by the tangent of 20 degrees. Sorry, that should just say 20 degrees. All right, to cancel it on the left-hand side. All right, so A, which remember stands for the length of the adjacent side, is 3 times 1 divided by the tangent of 20 degrees. Okay, so 3 divided by tan 20 is a decimal value. Now, if you watched my last video, I have some advice for you, which is if you're not at your final answer yet, maybe round to 4 decimal places just to kind of preserve accuracy, precision. And then when you get to your final answer, then you can round to 2 decimal places. It's going to save you from any headaches when you try to do clever and you round too early. So we're going to write this as 8.2424. Let's label that in our figure here. 8.2424. All right, so this is our orange triangle. Why don't I color code it now? Okay, and its area is 1/2 times its base times its height. So 1/2 times 8.2424 times the height of 3. And so that's going to be 12.3636. All right, but that's just the area of the orange triangle, and the orange triangle is the same size as all these other triangles, which we know there are 18 total. All right, so let's just multiply that area by 18 to get the total area. Okay, and now that this is my final answer, 222.54. All right, we're going to go ahead and round to 2 decimal places. Yep, okay. Cool. Should probably include units, inches squared. All right, thank you so much for watching.